Namaste. Welcome to tutorial series on process or bioprocess simulation using SuperPro Designer. In the previous video, we understood how to register pure components, stock mixtures required for this process simulation, and also we developed this particular process flow sheet of fermentation section. And in this video, let us initiate the streams and operations required for the process simulation. The first very important requirement in this is water. So the water is distributed to the multiple equipments. Let us register the water in this stream. Click select water, and you can notice by default it is auto adjusted. By default it is auto adjusted because we don't know how much water is required. Depending upon the downstream requirement, this water, the flow rate or the quantity of water is drawn from this particular stream. Click OK. Now let us first initiate this storage vessel or blending tank which is used for diluting the molasses. So we need to add the operation. Let us add the operation. First thing is we need to charge the water before adding the molasses. So water is coming from this flow distribution system, so we cannot charge it. We use the operation called as transferring. So once it is transferred in, the next very important thing is we need to charge the molasses. We need to charge the molasses. So once the molasses is charged, we need to add again water to dilute the molasses from 50% to 20%. Again, this dilution operation, so it is like a custom made one. We don't know how much quantity of water is required to dilute it. So that is the reason you cannot go with transferring or a charge. We need to use the pull-in operation. Pull-in operation. Once it is pulled in, once it is diluted, we need to take out the ingredients from this particular blending tank out of this blending tank to the filtration system. So these are the 4 operations required for this process. Now in this particular flow distribution system, so we need to set it. In the problem statement it says that so 100 metric tons of water is charged. 100 metric tons of water is charged. So let us select this one, the flow distribution system here, set by user. We uncheck these two systems because we don't know the quantity required in the later stages. That basically software will calculate it. So only the reason is here I have checked this because I know the quantity we need to charge it. So here we will select the unit as metric ton, a metric ton, and we will charge 100 metric ton. 100 metric ton. Remaining 2 we don't know, that will be calculated based on the later stages. The setup time and this process time we go with 60 minutes. Let all the parameters be in the default set as of now. And next one, we go to this particular blending tank. We initiate all the streams. You can rename the streams also, as I already told. For example, for your the convenience, what we can do is we can go to this add or remove operations. We can rename them. For example, here transferring is there. I will edit it as transfer water. Click OK. This transferring option. You can rename it as charge carbon source. Click OK. And dilute glucose to 20%. Click OK. And transfer to plate and frame filter. Click OK. Like this you can even edit the operations also. You can easily understand in the later stages. Now let us go to the first operation, transfer water. So already we initiated, that is transfer water 1A, and it's already available in transferring option. It's an intermediate. You no need to set what is the quantity. It will directly flow from the previous equipment. Here the setup time is 0. And also the process time, here it is 30 minutes set by user, that is process time is 30 minutes. By using within 30 minutes this 100 metric ton of water is going to be charged. And the next operation we need to charge the molasses, that is it is in charge molasses. So how much molasses need to be charged? As per the problem statement, we have not initiated this particular stream, so that is the reason I am selecting here. Again the same dialog box appear. The molasses is registered as a stock mixture. I will select the molasses. So according to the problem statement, yes, it is here it is. We need to select user amount on the stream. That is the reason it is deactivated. User amount on the stream. I'll go here, charge molasses. We need to charge 139.84. Sorry, before that we need to choose the metric tons. 139.84 0.84. Be careful. So whenever you add any numbers, first you have to choose the unit. So once you add the number and select the unit, it will be converted into the new units. So same thing happened now also. So that is the reason first you have to select the metric tons. So now 139.84 metric tons is required. So it is 100% molasses, no other component. So click OK with all the default properties. And also here the setup time is 0. The process time is 60 minutes. Here the process time is 60 minutes. Now once the molasses is charged, now we need to dilute the molasses from 50% to 20%. So again we need to set with an advanced properties. So we go with this set by other specification, setup here, and here set for the final composition. So we need to convert that 50% glucose or dilute that 50% glucose to 20%. That is the reason set final composition. Here we need to select the glucose as a target molecule and it need to be dilated to 20%. So based on this criteria, the water is drawn from this particular flow distribution system. Click OK. And next one, the pull-in stream, the setup time is 0, and the process time set by user, it is 30 minutes. So next one, we need to transfer this all these contents from this storage tank. It is telling glucose 20%. This operation required a valid port. Okay, we have forgot to select the port. So this is the water stream. So it shows an error. So we have not selected the water stream. The water 1B is the stream which is used for a dilution. And the next operation is we need to transfer the contents from the storage tank into the filter. So that is we can choose here. Yes, 108 is the port which is transferred to the filtration unit, and we are transferring 100%. Again here the setup time and process time, you can, instead of setting it here, because the transfer out operation of this particular storage vessel is depend upon the rate of the filtration happening in the plate and frame filtration. That is that we need to set it based on master slave relationship. So I'll select the master slave relationship. So here I will select another procedure. What is another procedure? Here there are a lot of equipments are available. That is the reason if you kind of rename them, it is better. You can easily understand. Here only one plate and frame filtration unit is there. I will select the plate and frame filtration 101. And what is the operation? We match with a single operation, that is filtration. So as the filtration continuously you are sending it to the filtration system, continuously drawn, and it is taken out. Click OK. So based upon the filtration rate of filtration, the process time is set to this one. Already setup time and process time is purely depend upon the rate of filtration. So all the operations in this is initiated. Click OK. Next we need to initiate the filtration one. So let us go to this operation, because as the filtration is a continuous process, it is basically it's a unit operation. Only one operation is available. And here we need to remove the impurities in the filtration system. We need to remove the impurities. We will select this particulate one, and we need to select the 90% impurities are removed here, and filtration is carried for 240 minutes, and the flux is the default flux. But here the cake porosity is chosen as 0.3. Cake porosity is chosen as 0.3 volume by volume, and rest all now as of now we go with the default values. And also you can notice the draw the filter from this particular stream, draw filter from S108, filtrate stream. The filtrate stream is nothing but S110. This is the filtrate stream and this is the cake stream. Click OK. There is no other operations, so only one operation. Click OK. So now the filtration system is initiated. Next, let us go to this storage option. As this is a batch storage system, again we need to add the operation. So what are the operations required? So again we need to transfer in. You cannot charge or you cannot pull in. So we need to transfer in. So that is we use a transfer in option. Once it is been transferred in, so when it is required, when it is sent to a chromatography column, it is transferred out. And also they have used one CIP step here, cleaning the tank using CIP. Click OK. These are the operations required. Let us initiate the operations here. In the transfer in operation, so what need to be transferred in? That is S110 is transferred in. Again we need to set with the master slave relationship. You cannot set the setup time, process time, because it is depend upon the rate at which filtration is happening. Then it is coming to this particular storage tank. That is the reason we go with the master slave relationship. Select here. The another procedure is PF101. The operation is filter. So click OK. Based on this, the time is set for this particular transfer in operation. The next one, we need to again select the stream, that is the stream is S111. This is the stream which is kind of sent used for transfer out and sent to the chromatography column. Again the rate of this transfer out operation is depend upon the rate at which the molasses is loaded into the chromatography column or ion exchange column. That is the reason again we set with master slave relationship. Select here. So another the operation the procedure is C101. This is the P5 C101. Click OK and match the operation. There are a lot of operations are available. It is basically depend upon load operation. Once it is you are loaded, again column is continuous. You are loading and taking out the purified stream out of this column. So click OK. So we have initiated this both transfer in, transfer out. Next very important thing is cleaning procedure. So by default the cleaning step, one cleaning step is available which required the pure component water, and cleaning is done for 30 minutes. Cleaning has been done for 30 minutes and we go with the volumetric flow rate per vessel circumference. Based on this criteria it has been set up. So that is 35 liter per minute per meter, and recirculation is 1. So all the other parameters are with the default values. Click OK. So we initiated the transfer in, transfer out and clean in place options, and further we go to this chromatography column. So in this chromatography column by default 5 operations are available, but we don't want this all 5 operations. In this the series of operation in this particular problem statement is we need to load the molasses. Again we need to regenerate it. We don't want this equilibrate option, and also we don't want this elute option. So we need to regenerate it, then further we need to wash the column. So these are the order. That is the reason 2 extra whichever by default available I deleted them, and also according to the requirement I reorganized the operation. So what is the first operation? We need to load the molasses, and also loading molasses it will continuously come out because impurities will go and bind to this resin, and we regenerate that particular impurities, and also further we need to wash the column for further usage. So click OK. Let us initiate the operations here. Go to this operation data, the load operation. Here in this load operation, so rest we go with default value. And what is the rate of loading? Loading flow rate, linear velocity. Here they have used 1000 centimeter per hour, 10,000 centimeter per hour, and also it is the we need to retain the impurities. Okay, that is the reason we will select retain product, because in purification step we say that retain the product, you remove the other content. In this case we need to retain the impurities, and resin binding capacity. What is the binding capacity of resin is 30 gram per liter is used, and we need to remove the impurities. Here you can see the impurities binding is like now 100% binding, because some quantity of impurities is already removed in the filtration system. Now the remaining impurities 100% we are removing here, and also the drawing system, the outlet stream is S115. You can notice here this is like, you can notice the waste outlet stream is like this is S115. S115 is the waste outlet stream. So this is basically we have set up this loading stream, and rest all we go with default properties. Next one, the next operation is regeneration operation. So here in the regeneration operation, again the elutant volume is based upon 2 bed volume. So of this packed bed reactor or the chromatography column, 2 bed volume is used, and regeneration buffer is used. Here in this case regeneration buffer is 1 molar NaOH. We need to use the 1 molar NaOH. We will charge the 1 molar NaOH. We go here, this is a stock mixture, we use 1 molar NaOH, and you can see it is auto adjusted. Based upon the requirement it will draw from this particular stream. Click OK. Click OK. And next one, in the previous section also you can notice here we set up all these things. The next one is we set up this one, and outlet stream need to be chosen. We can select this 115, and the rest all we go with the default parameters. Next very important thing is we go to this column wash. We go to this column wash. Here again relative to this one, again this wash solution we need to select the water as a wash solution, and we need to initiate this particular stream water. It is again auto adjusted. Click OK. And next one, the outlet stream is 115. Outlet stream is 115. So here also the flow rate is sent at 1000 centimeter per hour. We will see once in here also, yes, we need to set it to 1000 centimeter per hour. So rest all the parameters we have chosen. Click OK. And if you want, you can rename this particular stream as waste, so that in everywhere it try to appear. For example, if I go to this load, and you can notice now it is converted to waste, so that it's easy for us to recognize the stream. Here also this is a waste stream, regeneration buffer is added, and next one, the water is used for washing step, and 1000 centimeter per hour is the linear velocity. So rest all we go with default properties. Click OK. Click OK. So next let us initiate the storage operation. Here let us go to the add or remove operation. So what need to be done in the storage? Again we need to use the transfer in operation, transfer in operation, and again we need one more transfer out operation. Again they have used the cleaning step here. So these are the three operations. Let us go to this operation, transfer in. Again this particular operation is depend upon the rate at which it is transferred from the chromatography column. So we go with the stream is 114, from that it is drawn, and set by master slave relationship we go here. What is another procedure? C101, the procedure is load, because continuously loading, continuously coming. That is what the operation which is the storage tank transfer in flow rate depends on. So the next operation is the transfer out operation. So we need to transfer out from this 116 stream, and again it is purely depend upon the further equipment, that is here the sterilization equipment. The sterilization is PZ101, that is PZ101 match with the operation pasteurize or sterilize. You can rename this operation as sterilize. Click OK, and based on this the flow rates will be calculated. The next very important thing is CIP, same as previous our storage tank. It is 30 minutes. Rest all we go with the default values. Click OK. Once it is done, we need to initiate this pasteurization operation. So here the sterilization is carried out for 140 degrees centigrade, and the exit stream it is coming out with 35 degrees centigrade, because that is the fermentation is operated for 5 days at 35 degrees centigrade. So accordingly it will be cooled from the pasteurization unit or sterilization unit. So required temperature is 35 degrees centigrade, and also here you can set a cold exit stream. It's by default 60 degree centigrade is available. And also yes, rest all we go with the default values, but the process time given here is 480 minutes. 480, that is like kind of sterilized for 480 minutes. That's what the process time is given. So the all the inputs are set. So click OK, and next let us initiate this particular. This is done. It goes to this fermenter. Let us initiate ferment later. Now we go to this particular mixing, the custom mixer option. Again it is a continuous system, we don't need to set. Again here we don't know how much quantity is required. It is purely depend upon the demand later. So that is the reason defined by the processors, that is downstream. And also we need to add the components. The components are ammonium sulfate, and one more thing is nutrients. We don't need to select the water, because in the one of the tutorial I have explained. So if we have n streams, so we need to initiate n-1 stream, set the parameters for n-1 stream, other stream will automatically calculate by the software. Here the components are based upon the mass fraction. So ammonium sulfate is 0.03 mass fraction, and salts are 0.2. So another water is used. You can notice by default all they are initiated. So but I forgot to initiate this particular streams, so that is the reason we select here. We select the ammonium sulfate. You can notice auto adjust option is enabled. Click OK, and also here water need to be charged by anyhow it is the intermediate stream. It will be drawn from the flow distribution system. Nutrients need to be chosen. We need to initiate with the nutrients. Select the nutrients. Again it is by default auto select. So rest all we go with the default value. Setup time 0. Process time 60, and also we can choose the units in metric ton. That is what it represents in later stages. Volume also we can represent it in meter cube. So this is what it is being done. Click OK, all are initiated. Further again initiate the sterilization operation. That is sterilization is carried out for 140 degree 140. Previous one also we set at 140 degrees centigrade, and this also need to be set at 35 degrees centigrade, and rest all we go with default values. Here this is the process time is again 240. Chilled water is for cooling purpose. Click OK. So and also we need to initiate this air stream. Let us go and select the stock mixture air, select it, and auto adjust. We don't know how much air is required. Based upon the stoichiometry it will try to draw. So we will select auto adjust. Click OK, and let us initiate this compressor. So the air is compressed for 2 bars. So air is compressed for 2 bars here. And next one, the exit temperature from this compressor, by default it is 40 degrees centigrade, and time it will calculate but set by the user, but basically depending upon fermentation time it is continuously running. So it is 2 bar is selected here, click OK. And in the filtration system as such you no need to set up anything other than this process time also. So we'll go with this filtration default values, we'll see it later, click OK. And once all these are initiated, you should initiate this particular one also. Right click once, open it and click OK, otherwise you will get an error in the later stages. Now very important thing is we need to set the fermenter. So let us go to the fermenter. We need to add the operations in the fermenter, add the operations. What are the operations required in the fermenter? First very important thing is we need to send the carbon source, that is we need to transfer in from the sterilization unit. Next one, we need to add the nutrients, but we don't know how much nutrients is required. In the problem statement it is given some percent is drawn, so we based on criteria we need to draw it. That is the reason we need to use the pull-in operation. And the next one, they have used, as I already told in the when I read the problem statement, inoculum is not separately developed here. That is the reason they have used one option called as hold operation. This hold operation basically is a time for transferring the inoculum. So it is like in a batch process, the complete batch process time is cumulative of all these operations. So next hold operation. Next very important thing is ferment operation, because there is no kinetic information, stoichiometric equation is given, extent of reaction is given. Based on that we use this batch stoichiometric. And once the fermentation is done, we need to transfer out it to a storage tank and we need to initiate the clean in place procedure, that is click OK. So these are the 6 operations required in this fermenter. Click OK. So let us initiate one by one operation. So the first operation is transfer in operation. Right click and start with the transfer in operation, and transfer in operation is nothing but S117. And also we need to set it with master slave relationship, because the continuously the the media is sterilized and continuously sent, because this operation is a continuous operation. So based on this master slave relationship we select this PZ101 and the operation is pasteurized. So click OK. So we initiated the transfer in operation. And next one is we need to draw the nutrients or like other nutrients, that is from this particular S125. This is S125 stream. You can see here S125 stream. Select S125 stream. And also again we need to pull in based on the criteria. It is given here the mass ratio, added amount to initial amount. What is added already? The carbon source, the molasses is already added to the system. Based on added amount to the initial amount, it is 0.08. So the ratio is 0.08. Accordingly it will be drawn. Rest all we go with the default values. Click OK. Again we need to set with the master slave relationship, because it is continuously drawn from this system. So what is the equipment? PZ102 and the operation is pasteurized. Click OK. So this is again set up the pull-in operation. And next very important thing is hold operation. Here they hold it for 30 minutes. Basically this is for transferring the inoculum. Click OK. Next hold operation. Next very important operation is ferment operation. So here fermentation is carried out for 35 degrees centigrade. Cooling water is used for reduce the metabolic heat generated during the process. Air again is drawn from 120. Here it is drawn from 120. And air flow rate is given, that is 0.3 ppm. Again fermentation is carried out for 5 days. We select the 5 days. Okay, we have initiated this ferment operation. For next let us go to this reaction. This is very important. This is not fed batch. This is it is batch operation. We don't have to bother about this. That conversion it is given, 99% conversion is given. We set the stoichiometry of this process, that is ammonium sulfate plus glucose plus nutrients are charged plus oxygen. We try to give you biomass, that is Aspergillus niger, plus carbon dioxide. And next one it is calcium, citric acid. Citric acid is produced and water is again byproducts. So mass basis the stoichiometry is given, that is 2 ammonium sulfate, 180 glucose, 12 nutrients, 56 oxygen. That gives you 16 biomass, 30 carbon dioxide, 154 citric acid and 50 water. So you can notice both the size it is balanced. Click OK, and once it is done, they have also given the reaction heat. So you can uncheck this one, it is ignored, but now it is given. So enthalpy is given as -2990 kilocalories per kg. The reference component is citric acid. And the temperature, operating temperature 35 degree centigrade. So one more thing you should remember, if you are not set up this equation, you cannot able to select the reference component. So first you have to set up the equation, then only the drop down menu that particular component will appear. So we have initiated all the components required for reaction, and the next operation is transfer out operation. Transfer out through this particular S23 stream, again set by master slave relationship. It is based upon the V104 P14 V104, that is store option. Click OK. So it is dependent on that one. Next operation is clean in place operation. This is very important because in the previous steps we have just in a simple way initiated the cleaning operation. Here the first cleaning is done using water. So that is, it is renamed as water flush, and the next one more step is there. We need to add the sequence, insert before, insert add. One more cleaning step, that is caustic flush, and once this caustic flush is done, again one more water wash is done, that is water flush toe is done. Toe is done. So click OK. These are the three washing step here in the cleaning place. We will set up the first one. So duration is done for 10 minutes. Duration is for 10 minutes water wash, and water is the pure component. By default it is chosen here, and here the water, the flow rate is 30 liter per minute per meter, and we need to recirculation is not required, so we will just go with default values. And the next operation is caustic wash. It is done for 30 minutes. Here the 1 molar caustic is used, so it is not pure component, this is stock mixture we have registered, that is 1 molar caustic is selected here. Again it is drawn at 30 liter per minute meter, and here the recirculation is selected. 3 times it is recirculated, and rest all, that is the reason I checked here, flow is recirculated, 3 times it is recirculated. And next operation is here water wash, that is for 10 minutes, and again it is pure component stock mixture, it is the flow rate is again 30, and there is no recirculation. Rest all we go with the default values. This is the step for cleaning step. So this is CIP is initiated, almost all the operations are initiated. We'll right click on this storage, and we initiate it. Storage based on adiabatic, we'd all go with the default values, because again this storage depend upon the later downstream step, what rate it is drawn. Based on that, the storage, as it is a continuous one, automatically the flow rates will be set. So click OK. So this is how we initiated all the streams, procedures, operations inside the procedures. So in the next video, let us simulate this particular process flow sheet, and if any errors, we will try to rectify the errors. If there are no errors, we move to the further step, that is downstream processing. Thank you for watching. Please do not forget to subscribe.